All right. So welcome everyone to today's webinar. We are going to have a deep dive all about marine debris. And as usual, please keep your microphones muted and you can submit any of your questions to the chat. You can submit those questions to everyone so people can see it, or you can submit them directly to Dolphin Communication Project. Just choose that from the drop down, and then we will get to your questions at the end. I remember that we're recording, so you may also want to keep your videos off unless you want to make a surprise appearance. I am very happy to welcome a longtime DCP friend and colleague, Dr. Christine Ribick. She is the unit leader at USGS Wisconsin Cooperative Wildlife Research Unit. And I'm glad that I didn't have to memorize that before introducing you, Chris. And she's joining us all the way from Wisconsin. And there you can see her on a beach with sad marine debris. So with that, I will turn it over to you, Chris. Thank you so much and welcome.
All right, well, thank you, DCP, for asking me to talk about this issue. I've been working in marine debris for most of my career on various aspects of it, and wanted to give people my perspective of what I've learned from all the work that I've done. Currently, marine debris itself is a widespread and globally recognized problem. You may actually be familiar with it because there's been a lot of publicity around the Pacific garbage patch. But marine debris is much more than the garbage patch, and it's really quite a complex problem. And so today, what I'm going to talk about briefly is what it is, why it's an issue. You might not have thought about all the impacts it might have. So I'll talk about those. And then things that I actually have been really curious about is sort of what are the drivers and mechanisms that actually concentrate debris, and can any of information about those help us with any kind of mitigation strategies, how to prevent this. So what is marine debris? Of course, we have always defined things. Scientists always do that. And the first thing to understand is we've been worrying about this problem since the mid-1970s, and it got the moniker marine debris because of how it started. It started when researchers on the Pribilof Islands in Alaska saw their fur seals with strapping bands, plastic strapping bands around their necks, causing harm to the animals. At the same time, there were people walking around the beaches of the United States and seeing gulls with six-pack rings wrapped around their beaks. And so that kind of sort of started this whole issue. It was marine debris because it was noted in the ocean at first. So the National Academy of Sciences defines it as solid materials of human origin that are discarded either at sea or they reach the sea. And they do that through waterways or domestic industrial outfalls. UNEP, United Nations Environmental Program, has updated it a little bit, talking about persistent manufactured or processed solid material. It's basically, the one thing that's nice about this issue is there is no actually argument about who causes it. We cause it. We cause it. It's a consequence of how we manage our solid waste, what we use for packaging things. There is accidental loss or intentional discarding of things at sea by people who are working out at sea, either fishing or cargo or ship-generated debris. There's also, around the world, there are some places that don't even have an infrastructure to handle their waste. Think about islands in the different parts of the world. And then there's people have indiscriminate human activities, AKA littering. And a lot of times, we don't even understand consequences of our actions. We just sort of throw it away and it sort of disappears. So that's where it comes from. It comes from us. And so what we have is we can look at our society as a marine debris generating system. And what we see in this complicated figure that I've adapted from a research article is all the facets of marine debris. So what we have is showing you how marine debris comes from the beach onto the beach from cities, people on the beaches. It gets into the water from a variety of ways. Wind is one way, water is another. It ends up in the near shore. And we also then have our cargo ships, our fishermen, also depositing debris in the ocean. And they all start to then be affected by the circulation system. We have animals that interact with it. It sinks to the bottom in all these places. And something you might have noticed, I think last week, there was a report of there's plastic in our air. And what that is it's coming directly from our cities and a little bit from the burping in the ocean, believe it or not. And so we have plastic particles falling in the Grand Canyon, and we are starting to breathe that. So as you can see, we're starting to see this whole marine debris generating system as a big cycle that's affected by our different water and air circulation systems. And so what we do is, because you noticed in that figure, things are coming from land, things are coming from the ocean. In order to understand this whole problem, we actually have started to look at specific kinds of debris, what we would call land-based. That's debris that is generated by activities from land. And these are examples: metal beverage cans, balloons, six-pack rings, a lot of things having to do with sewage. And that's because many cities, this is actually from Israel, a project that I was on, believe it or not, your sewage outfalls go right onto beaches. And sewage outfalls do not have screens. And so this is what comes out. And you can see here, a flip-flop. People on beaches leave this. And then what happens is high tide comes in and it swings right back out into the water. And so that's what we mean by land-based debris. But there's also the ocean-based debris. And ocean-based debris is what you think about fishing, right? Here's our ropes, here's our nets, here's our baskets used. But there's also light tubes that divers use for fishing. This is your light bulbs used on vessels. And something we don't think about, spacer tubes in aquaculture. They use them to grow oysters, and they're found on the coastlines. But this stuff washes out into the ocean, and this is actually from Midway Atoll. In the middle of the ocean, we have spacer tubes, and these actually come from Korea. So even though it's ocean-based, we're using things in the ocean. We also can be close to land. So just don't think it's just fishermen out in the middle of the ocean that's dumping things, because it's not quite that simple. And then the thing that you're probably most familiar with is plastic waste, plastic bottles. We've called this general source because it sort of comes from everywhere, but recent research has pretty much indicated that it's likely mostly coming from land. And it's not just the plastic bottles that you find. You also find a lot of the tops of the plastic bottles end up just sort of getting separated from the plastic. But this is a huge, huge part of what marine debris is made out of. So let's give you some examples. And I'm going to take examples from work that I've done, and you'll be hearing more about these projects later in the talk. So these two studies, the coastal United States and Israeli coast, were done with beach surveys. Beach surveys are very popular because that's where the water and the land come together. And so you can really get an idea of what's out there. And research has shown that what's close, sort of in the coastal region, if you do a survey specifically out there, it is reflected in what's on the beach itself. So here you can see that we got a lot of plastic bottles on the coast. 35% of the debris is made up of plastic bottles and plastic waste. Land-based ranges from about 47% here in the US to over 60% in Israel. And the amount of ocean-based basically depends on how much of a commercial fishing and shipping industry you have. And we actually have more of a commercial fishing and shipping industry than Israel. And so that's what's the difference in how much you see on the coast. Now, if you go in the middle of the ocean, like Midway Atoll, you can see how it flips. So nobody lives on Midway Atoll in the terms of, and all waste that are there is basically segregated. So it never gets at all onto the beaches. So this is all stuff that's getting washed up onto the beaches. it's really similar in terms of plastic bottles and stuff floating up. But what's interesting for here in the general source on Midway is most of that is your plastic bottle caps. But again, Midway Atoll is in the middle of the Pacific Ocean, and there's a lot of fishing, and there's a lot of aquaculture in the area around the Pacific Rim, and that's what ends up here, and that's why it's the highest compared to these other two places. Now, the thing that people concentrate on now is that almost all of our marine debris is plastic, and that has been tracked in many different studies. This is the global growth in plastic production up until 2012. And in a study that I did early in my career, this is actually plastic pieces that were found in tropical seabirds along the equator. And basically what we have is an increase as we have an increase in plastic. So animals themselves can actually give us information and track what we are doing in terms of our marine disposal system. So now I'm going to get into quickly the impacts of marine debris. There are 4 general categories: economic impacts and human health impacts, so those are directly on us; wildlife impacts, which are entanglement and ingestion; and then ecosystem impacts, smothering and physical damage. And I'm going to go through them all just to give you an example of sort of what we're talking about. So economic impacts, vessels are damaged, and so they have to be repaired. That costs money, so that's a direct economic cost to individuals, and various studies have tried to measure that. There's also a direct cost to coastal municipalities. Any municipality that basically has tourism, they clean their beaches. They go in and wipe this stuff off, and so they have to spend taxpayer dollars or somehow money to actually get that done. It's not just the actual physical cleaning, but the cost having to do with somebody having to do the contracts, etc. There have been some interesting work on indirect economic impacts, where there's actually the loss of revenue because tourists don't come to your beaches. And it's a local loss, not an overall loss, because what happens is instead of coming to your place, they go someplace else. And this was actually seen in Korea, where they had a really bad wash up of debris, and the tourists basically checked out of their hotels and they just moved away. There are a variety of human health impacts that we see. Sewage debris on beaches is actually common in the United States, and will close your beaches, particularly if needles will wash up. But new things that are coming to fore are plastic pieces in the water can actually concentrate bacteria, and the bacteria can make humans sick. So there becomes a water quality issue of you swimming in plasticized water. And the most recent one, of course, is the fact that people are starting to breathe plastic particles. My prediction is we're going to see a whole lot more work on human health impacts, particularly because of this breathing issue. But what about animals? Because that's really where it started. Entanglement is probably the most obvious one. This is a turtle entangled here. And there's also other animals, just name it, any animal, you probably have an entanglement photo. But also don't forget, an entanglement also includes ghost fishing and also this trap. If a lobster trap is lost, where the rope that tells the fisherman where it is breaks off, it'll stay here and it will fish and fish, and the animals die in there because they can't get out. Now, this was actually recognized, the trap issue, early on, and actually now most traps have a decomposable part. They're not all made out of plastic, but they actually will have a part that decomposes, so at least on the trap end, after a while, it stops fishing, which is great. But there's still issues having to do with ghost fishing of nets. And the reason why we're concerned, it's really hard to actually measure an actual impact other than for individual animals. But the monk seal, which is here on Midway Island, is actually an example where marine debris has actually impacted this specific species. This is the most endangered pinniped on the planet. There's only a couple hundred of them. There's very few of them. And so what happens, they noted, is that young seals like to play, and they will entangle themselves in these nets and they will die. And that is an actual problem when you're trying to basically recover a species. And so now what happens is On Midway, they definitely go in there and they take all this netting off the beach. I know there's a lot of trying to cut netting before it goes overboard. All of this because it was a direct impact to the animals. Ingestion is what you're hearing most about a lot. And it comes about because plastic degrades. It doesn't really dissolve. It fragments into those plastic pieces. What's up in the upper left corner is an example of what comes out of a newsstand net when you tow something, and that's in Israel. Plastic pellets are different than plastic pieces. Plastic pellets are actually what we make our plastic products from, and they will spill. And like in the Great Lakes, it's a really big problem there. And what you also see is dead birds on the beach, and this is the kind of stuff they eat. They'll eat, and what they eat depends on how big the animal is. But again, these animals are just trying to find something to eat, and so they ingest by just going on the water, picking up stuff, and that stuff happens to be plastic. So the reason why we're really concerned about this is because we know that adult birds will clear the plastic from themselves, but the concern is, what about the youngsters? We know, for example, on Midway Island, these youngs get fed plastic by their parents. And so there's always this concern, though we can't really measure it very well, that having them eat plastic, it just can't be really good for them, right? So that's a lot of the problem with ingestion. And you've probably seen in the news things like the whales that die and they're impacted with plastic, or the turtles who think plastic bags are jellyfish, so they're eating them. And you probably wondered where I was going to bring in dolphins. So for showing us that, yes, dolphins like to play with objects, including marine debris. In this case, nice piece of plastic. And in fact, when you look at the animals that ingest or get entangled, dolphins tend to ingest more plastic. There's more reports of ingestion problems than there is entanglement problems. But basically, marine mammals, marine birds, and anything that might ingest things, so all the way down to zooplankton, will be affected by marine debris. Okay. So if we get away from the warm and fuzzies, there is ecosystem impacts to the other parts of the system. So coral is particularly problematical because they can be smothered by debris, by netting. They can be physically damaged by things. Yes, that is a tire, and that is found on the bottoms of when people do benthic debris surveys. And there's also the whole issue of plastic bottles and debris being used as habitat by animals. And they're trying to understand if animals are actually affected if they use plastic rather than shells, for example, for their habitat. So as you can see, it's pretty pervasive. And the impacts, you can just keep on going. But I don't want to keep on going on impacts. What I want to talk about is the drivers of marine debris, because human activities and physical processes are going to affect what gets deposited and where it actually concentrates over time and space. And different drivers can affect land-based and ocean-based debris, and also where you are when you do your study. So there's local and regional drivers, and the hope then is if you understand something about those drivers, it might give you some insight into what management strategies you could use to reduce debris loads. So just going into the marine debris generation system, just to remind you, I'm going to talk about processes in the ocean, the near shore, and the beach. And I'm going to talk about them that way because ocean is actually really easy. We know what's going on in the ocean. Near shore gets more complicated, and the beach is the more complex yet. So that's why we're sort of going from easy to hard. So it's easy for the ocean because so physics drives everything in the ocean, whether it's the water and the air. The oceanographers know what's going on. There isn't any question. This is what the garbage patch looks like when you ask the question about what's going on with all the different circulation systems. The garbage patch is there because it's a convergent zone. There's nothing going on that is very like a dead zone. So everything concentrates there. There are divergent zones. You don't see a lot of debris down there. And in fact, in a study we did in our study, we were south of the equator in a divergent zone. And when you compare animals from the up north to the animals down south, up north have more plastic in them because they end up feeding in these convergent zones, not what's going on down south. There isn't that concentration. So that's the complex, but we know that. We know it because of these, of the physics of the system. And so there are garbage patches all over the world's oceans that are defined by circulation systems. Physical drivers, when we're near shore, become much more complex because wave-induced currents are driven by radiation stress and wave breaking along the coast, and they're more chaotic. Wind-induced currents are wind stresses that actually affect the free surface of the water. Again, we can tell you that the wind is coming from the north, and that gives us our wind-induced currents, but how wave and wind interact is very hard to measure. And in fact, if you put your monitoring systems in the coastal areas, they can actually get destroyed because of the high energy. So that's what makes it more difficult to actually predict what's going to happen. And so that's why I wanted to turn to the project I did in Israel with some colleagues. So Israel is down here in the lower right part of the Mediterranean Sea. And this is what the Mediterranean Sea looks like in terms of its circulation pattern. And so when this project started, my colleagues thought that Israel was really just sort of a sink for marine debris, and it just sort of all was coming onto the shores of Israel, and that nothing was really sort of getting out into the Mediterranean. And so they were doing a multifaceted evaluation of debris on the beaches in the near shore on the bottom, and so that's sort of a holistic view of what was going on there. So this is from the beach surveys, and the yellow are these. So this is the composition of the debris, and from south to north, you can see there's variation in how much land-based debris. And they wondered if some of this increase was due from debris going from the south to the north, because the general circulation pattern along the Israeli coast is from south to north. So in order to understand that, they did an experiment where they actually threw bottles at different distances from the shore at these different areas from south to north along the coast. And they were 1.5 liter plastic bottles, drinking bottles. They put sand in them so that they weren't just floating on top of the surface. They were actually getting the current. And in there was a message for someone to please email these people to give them just the latitude and longitude of where it was found, and then to please recycle the bottle. And so they did this. They let it go for about 2 years. And by the way, they didn't have to buy any bottles. All of these bottles were found bottles, or they got them from recycling centers. So they didn't buy anything. And they also promised, when they got their permit, that for any bottle that wasn't actually found, they would remove 3 bottles off the beach or out of the water for every bottle not found. So they were committed to not trying to increase debris in the ocean by doing this experiment. So again, what the expectation was is that things from the south, so by Zikkum and Ashkelon, Nitzanim, and Ashdod, would go up to Akko and Haifa. And that was the expectation. So what did they actually find? Well, it turned out that they were wrong. We were all wrong. All of the bottles that came from the south stayed in the south. In fact, they recovered almost 100% of those bottles. What they didn't recover were the bottles that were from Haifa, up northern Israel. And what it turned out is those bottles ended up floating around the Mediterranean and ended up by Greece. So what they learned is that Israel is not just getting debris from other places. They're also an exporter of debris, which is a little shock to the system, but it shows you how complex the system is. So now what I wanted to do is move to the beaches, because beaches have been that traditional focus of marine debris work. And they're more complex because you have 2 things going on: land-based forces and ocean-based forces. So They're much more complex. The physical processes are more complex. Coastal currents are complex, but beaches themselves are dynamic. They're not static. So there's turnover and things going on beaches. Plus there's human activities on the beaches and how humans use that area, both on shore and offshore. So all of this stuff affects what kind of debris you're going to see on the beaches. And this brings me to the Coastal Marine Debris Project. This one was done, it was a joint project between NOAA and EPA. And what we did is we did beach monitoring for about 10 years, actually, off the Atlantic, the Gulf of Mexico, Pacific, and Hawaii. And they did that because at the time NOAA had a marine entanglement program. They were concerned about entanglement debris. EPA actually is concerned about debris coming from land under the Clean Water Act. And so the question is, could they get, and Congress wanted to know what was going on, and so they wanted to get some information. And so the whole point of that project was to look at amounts, composition, and trends. And we used indicator debris on beaches of the United States. And we looked at the continental, coastal, and regional scales. Wrote a lot of papers about it. I'm not going to read you those papers, but I just want to tell you that this was actually all done by volunteers. This was one of the first citizen science projects that was done before citizen science was cool. But we never, ever could have done this project without the volunteers. People who like to walk on the beaches and were willing to use the protocol that we have. And without them, without citizen scientists, we'd never have the information that we did. And about 500 meters is about a quarter mile of a beach, by the way. And they did it monthly, including Christmas and New Year's. It was interesting. So I'm just going to talk about the Atlantic coast. And I'm going to do that because there were three areas of the coast was divided into three areas based on circulation. So there's the Gulf of Maine, so north of Cape Cod, then south of Cape Hatteras, that's affected by the Gulf Stream, and that's the southeast Atlantic. And then the mid-Atlantic is where they both come together. And if you want to guess that there's more debris in the mid-Atlantic than in the Gulf Coast and southeast Atlantic, you would be correct. Because basically, things are converging onto the zones on those beaches. But what we were interested in is trying to understand what was the differences in debris deposition, both land and ocean, based in those three areas. We knew population is different. We knew fishing is different. There's shipping differences. And so we were actually curious about that. And so we looked for land-based. We were curious about how the local population size affects how much debris you see. What would tourism do? If it mattered whether the local population had waste management programs like recycling or not, and also how the site was used. So there are sites that are recreational sites. You can do whatever you want, but there's also more refuge style where you can't. You can come and visit, you can come look, but you're not going to be playing Frisbee and having a picnic there. They don't have the infrastructure for that. It's set aside for a different purpose. And then ocean-based were things like commercial fishing, shipping, and we are looking at the distance of the site to the closest commercial port, and then of course commercial fishing. We couldn't really get a handle on recreational fishing, and also commercial fishing on the East Coast is such a big thing that we felt we wanted to look at that. So we looked at all these various things, and this is basically a real typical example. Basically, as population size increase, that's the local population within 40 kilometers of a site, you get a lot more land-based debris. But there's a threshold for it. So it's not a linear increase, it doesn't continually go up. But basically, if you have large coastal populations, if you have cities that are more than 250,000 people, if they're close enough to get there, so you can have day tripping, And if you have sites open to do whatever you want to do on those sites, maybe not surprising, but you have more land-based debris on the beaches. And a lot of it has to do with what kind of infrastructure is on the beach. Do they have places to put the garbage, or is that empty? There was one place up on the East Coast that had a ton of straws because there was a place that sold drinks that had all these straws. And so they ended up being a hot spot for straws because they were handing them out to people, and people were just sort of dumping them on the sand. So those are the kinds of things we started to see. So how you use the site is really important, and you can start thinking about what you might want to do to decrease land-based debris, if you can. What kind of things people might want to change. Now, for ocean-based debris, what we found was interesting is the expectation, of course, is that if you have more commercial fishing, you should have more debris on your beaches. And in fact, in the Gulf of Maine, that's exactly what we found. That when there was a lot of fishing activity in the current month and the month before, you had a lot more debris on your beaches. But we didn't find that in the Southeast and the Mid-Atlantic. So we were wondering why that wasn't happening. And it turned out because at the time of our study, the Mid-Atlantic and the Southeast Atlantic commercial fishing industry collapsed. And so what we had was actually our yearly debris loads basically tracked the decline in the yearly commercial fishing activity as it went down. And what that means for people interested in marine debris is that if you have a stable commercial fishing activity, the price of having that stable commercial fishing activity is ocean-based debris on your beaches and in the water. And you have to think about why these people are maybe discarding, or it might be falling over, because it's there's no incentive for them to bring their garbage back when they want to fill their boat with something that is going to be economically viable or important to them, like the fish. So think about how we might want to be changing behaviors and all that kind of stuff. So getting back to human behavior as part of the issue with debris. And that's what this brings us back to, is how we act, our choices that actually drive this problem. So overall, marine debris is a consequence of how we deal with our waste, what we use, how we dispose of it, what kind of incentives we use to get people to stop littering. That means it's really complicated. There isn't a silver bullet that's going to fix any of this stuff. And what's really interesting to me is how the issues around marine debris changed over time. At the beginning, it was the animals are really being impacted. Nobody wants to see dead animals or entangled animals. And so they actually did things. They actually changed human behavior. So strapping bands now are split. You will not, in our work, we never saw a strapping band that wasn't basically cut. Because of the issue with gulls and the six-pack rings, that's why six-pack rings are now designed to break apart. So we have a way to attack these problems depending on if it's important enough. And I do want to emphasize that so small changes can really have large effects, and how you buy products and how your local community handles debris really does matter in terms of what's going to be out into in the environment, and what the environmental system is going to have to deal with, particularly since plastic is basically what we make our stuff with, and it hangs around for a really, really long time. And so hopefully something will happen, or we'll be able to fix some of this stuff so that the dolphins themselves might want to find something else to wear. Okay. So thank you for your interest in ocean conservation. And that is, yeah.
A reminder to everyone, whether you're listening live or in the recording, that all of our webinars are available on our website under the Education tab. They're also available on YouTube, so you can subscribe to Dolphin Communication Project and make sure that you never miss an episode. And we can go to the next slide, and I'll show you quickly a reminder that in addition to our webinars, we also have our podcast, The Dolphin Pod, and that is available wherever you get your podcasts, and you can also listen directly on our website. This was the finale, the spring semester finale webinar. So we thank Dr. Ribic for being that presenter. But we do hope to resume our Dives Deep programs and our dolphin lessons later in the summer and certainly the fall semester. But we do invite you all to a world premiere viewing, if you will, of DCP's 20th anniversary film. That was put together by John Anderson of Terramar Productions. And we're going to show that next Tuesday at 7:30 p.m. Eastern. So if you want to join that live showing, some DCP players will be available afterwards for some Q&A. And then the last reminder to you all is just how to support us. So we can look at that last slide for a minute. And you can find our website full of information, stay in touch via email, our social media is there. And of course you can support us by purchasing things from our website as well. And at least as of right now in the live recording, those asterisk programs, we're still running our Pay It Forward campaign. So anyone who spends, or for every $15 spent on Adopt a Wild Dolphin kits, memberships, shirts, bandanas, for each $15 spent, DCP will donate an electronic adoption kit to someone in need. So whether that's an essential worker who is working real hard and putting themselves at risk, or someone who just needs pick me up, we want to spread a little joy and thanks and dolphin information. So with that, if it's okay, we will answer some questions. Sound good, Chris?
Yes. Do you want me to stop
Awesome.
sharing? There we go.
Yeah. So one of our first questions is acknowledging that it seems like a huge challenge to actually catch people who might be dumping in the middle of the ocean. Are there technologies being used to catch the perpetrators of intentional dumping? And I would also add, are there even laws that govern international waters?
There are laws that govern international waters, but as you might imagine, trying to catch someone in the middle of the ocean is almost impossible. There is technology that is used to try to track pirate fishers, fishing vessels, but I think that problem is of more importance than whether they're dumping things over into the ocean. I do know there was an investigation in the Gulf of Mexico into the shrimpers dumping debris. They actually dump onion bags full of their debris that wash up on shore in the Gulf. That became very, very dangerous because the person who had called them on it was actually threatened. It was a National Park Service person who was doing that. So while it would be nice to catch people, when law enforcement gets involved, it can become a little contentious. And so that's why most of the work is done to educate people, to try to provide facilities where they can bring the debris, the garbage back, so that they won't feel that they have to dump it overboard. And try to incentivize to have them bring it back. There's is there something we can do to recycle this stuff so that they have a reason to come do it. Rather than enforcement, it's always trying more of a carrot approach.
Thank you. And thank you for the question that was from Eric. what would you, referring to the coastal US study, is there something that surprised you the most out of those results?
There's a lot of interesting stuff. So what surprised us was the fishing stuff. The fact that it was like, oh, if you're going to have a viable fishing industry, that's the economics comes in, and then it means you have to really start scratching your head to figure out how to help these fishermen, because when you start looking into it, like marinas don't have enough places to put their stuff, etc. But what I thought was surprising too was, okay, we did work on California, so in the Los Angeles basin, and you would think that that is the place where you would find the most debris, and we did not. And the reason that we think is because it turns out that California, in the Los Angeles basin area, actually has laws against putting stuff into the streams that lead into the ocean. And it apparently, if you look at the others, it apparently, we're actually seeing that, reflection of, we can't prove it because we didn't know about this going in. We were just, counting the debris. So I found that really heartening, that actually local laws could actually affect what you're actually going to see on the beaches. We're also surprised at just the amount of variation. There's a lot of local stuff going on that if we could only, get a handle on it, if people were interested enough in it, they could actually, like the concession stand that put out all those straws. I mean, it's like, if you could just get them to stop putting those straws out, you would have done a whole lot of good. So getting, sort of looking at these site-specific variables and saying, hey, for this area, you might be able to help by just doing that simple change of don't put out straws. So it was, I was very fascinated by what we found. I could keep going, but I'm not going to.
You shared your work in the Mediterranean and your work on the U.S. coastlines. I would imagine that it's very disjointed in puzzle pieces that don't necessarily come together. You mentioned the UN Environment Program. Is there like a centralized monitoring system for isolated studies to try and get a global picture of what's going on?
So there isn't any central place. There are different recommendations on how to do surveys. UNEP actually has one on their website. But actually what I found really interesting is out in the European Union actually has a program to look at marine debris in the European Union. And they look at it from the point of, if we do something to stop it, will we see it reflected in the environment? So they have a standardized program. And in fact, the Israeli project tried to use that because they're in the Mediterranean. But no, there is no centralized, everybody do it this way. And that's because it's really site specific. And what do you want to count? So for example, we had a lot of trouble getting to information from the Western Gulf of Mexico beaches because there was so much stuff on the beach. Just on the stuff we were asking them to pick up, the volunteers couldn't do it. They would drop out. And so a quarter mile was too much for the Gulf of Mexico, is perfectly fine for Hawaii. So that's why it's hard to do this one size fits all. And so all we can do is give you best practices, make sure you understand why and how you're going to measure and what you're actually measuring. Because if you go onto a beach and it hasn't been cleaned in a long time, we do know there's what we call standing stock. This has been there for a long time. And is that what you want to measure, or do you want to know what's coming on? And then at what scale do you want to know that? So that's why it gets a little complicated. But I really like the European Union program. They've integrated debris into water quality, environmental quality. It's no longer this sort of thing over here. It's actually integrated, and that's really cool.
Certainly seems like a hopefully more effective approach in the long run. Are you familiar with the Ocean Conservancy's Clean Swell app? Here we do beach cleanups, as you know. Chris has been to Bimini and done a beach cleanup with us.
Right.
And we just kind of, with our field courses and our eco tour groups, go out on the beach in Bimini and clean up as a way to keep in mind our impacts and give back and have a discussion and whatnot. But we've never kept track of the pieces of garbage. We've just compiled them. Do you think something like this is kind of worth looking into, might be effective? I've put you
So,
on the spot.
no, you haven't, because I actually work with the Ocean Conservancy. They're the ones who did that, the marine debris program. And then they stopped that program. I mean, it changes, but Ocean Conservancy is the one who actually was the partner with us to get all that field work done with EPA. And in fact, we looked at their annual, the annual Clean the Beach programs they do in the fall. The problem there is those programs are more public outreach programs. They're not really data, because they don't keep track of exactly what is surveyed. They don't have a protocol. They do get some general patterns. I mean, I agree with them. If you look at what's on those beaches, there's a lot of cigarette butts on your beaches, you know. So you get sort of these general things. But in terms of what we as scientists would say is controlled enough, no. But is it a good thing to do? Yes. Yes. And you're going to get people involved. You'll get them aware of the problem and start asking questions. How can I stop it? Because if all we ever do is keep cleaning up beaches, we're just going to be the garbage people of the world. And really the question is, how do we stop at least some of this stuff? And getting people engaged that way is a good way to start that conversation.
Thank you. Yeah, on Bimini, when we do beach cleanups, I always think like when we've collected a lot of garbage, we feel good because we did that, but we feel sad that it was there. And then if we have a day where, oh, it was only a couple of garbage bags, we feel as if we didn't do a good job cleaning, but then we have to remind ourselves, oh, but it was a good thing that there wasn't garbage on the beach.
That's right. That's right. That's a good thing.
Yes. I saved this one for last because hopefully it will end on an optimistic and empowering note. What do you recommend for people to do in our own lives to stop adding debris to the ocean?
Yes. Well, if you can use reusable bags, I know you can't do it now with COVID. That's been stopped. But anything to reduce the waste that you generate. So just the simple things, using a bag instead of plastic bag. Even I'd say take a paper bag over a plastic bag, because paper at least will decompose. Plastic stays forever. Don't use straws. Use the metal straws if you can. Those are the simple things. Try reduce packaging. I do know that I think a couple of days ago, there are some places in California and other places that are going to start banning single-use items that you like, you know, the plastic forks and things like that. So if you buy something in a store, try not to take all that other stuff with you, because that's the stuff that ends up on the beaches and in the water, and it's a problem. So actually people can do a lot to reduce your disposables, like just throwing it out. And to the extent you can do it, that's great. I think anything is better than nothing. So the reduction in packaging would be really good.
Fantastic. Well, thank you to our listeners, live and recorded. Thank you for people who submitted questions. And of course, the biggest thank you to you, Dr. Ribic. Thank you for leading us through this topic and answering our questions. And I look forward to seeing you again in Bimini one day.
All right. Well, thank you very much.
Excellent.
Okay.
Thanks, everyone. Bye.
Bye.